minimum spawning tree and Prim's algorithm. A minimum spawning tree is a spawning tree that has minimum weight than all other spawning trees of the same graph. Let me take one example. Suppose if we have given a graph 1, 2, 3, 4. So we have already seen in the last lecture that then we are able to create 4 spawning tree. So 4, 1, 2, 1 spawning tree and 4, 3, 2 another spawning tree. Then we have third spawning tree, 1, 4, 3 and then the fourth spawning tree. 1, 2, 3. So out of this 4 spawning tree, what is the weight of this tree? It is 4 plus 1 plus 2 is 7. Here 7 plus 2, 9. Here 8. And what is the weight of this spawning tree? 6. So now from the given graph, we are able to get the 4th spawning tree. Out of these 4 spawning tree, the last tree has the minimum weight. So we call it a minimum spawning tree. In real world situations, this weight can be measured as a distance, congestion, traffic load, or any arbitrary value denoted to the edges. Prim's algorithm is a famous greedy algorithm. It is used for finding the minimum spawning tree MST of a given graph. To apply Prim's algorithm, the given graph must be weighted, connected, and undirected. So what is Prim's algorithm? Or what is its procedure? So first, we randomly choose any vertex of the given graph. The second step, the vertex connect to the edge having least weight is usually selected. Third, find all the edges that connect the tree to new vertices. The fourth step is find the least weight edge among those edges, least weight edge, and include it in the existing tree. Next step is if including that edge create a cycle, then reject that edge and look for the next least weight edge. Keep repeating above steps until all the vertices are included and minimum spawning tree MST is obtained. Let us take one example, then it will be very clear how to construct the minimal spawning tree for given graph using Prim's algorithm. So now we have given a graph. It has 7 vertices, 1, 2, 3, 4, 5, 6, and 7. So there are 7 vertices and there are different edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges and 7 vertices. So what is the step number 1? The minimum spawning tree can be obtained as step number 1 is we have to first select what is the minimum, any vertex we are able to select. So now if here we are independent, we can select one as a one vertex, first, 2, 3, 4. So we have choice that out of these 7 vertices, we are able to select any vertex, any vertex. So let us take 1 as the first vertex because the serial number is given. So let us take 1 is the vertex. Now, the vertex 1 is connected to two edges, two vertices. One is 6 and another is 2. So out of these two edges, the weight of first edge is 10, the weight of second edge is 28. Out of these two edges, this 1 to 6 has the minimum weight. So we first consider this edge. So now we go from 1 to 6. Now in the second step, in step number 2, after that, we just look here from 6. There are two vertices now we have 6 and 1. So 6 is connected with 5 by and weight by a weight 25. 1 is connected to 2 by the weight 28. So out of this 25 and 28, 25 is minimum. So we again select the age 6, 5 whose weight is 25. So in the step number 2, we are uh, selected the another age 25. Now after that, if we go to the 1 and 5, the 1 is connected to 2 by the weight 28. 5 is connected by 27 by weight 24 and 22. So 22, 22, 24, 28. Out of this 3 weight, this 22 is the minimum. So the next step, we have to select this vertex 4. So now we have 1, 1, 6, 5 and 4. Now after that, let us see here these vertices 1, 6, 5, 4 are connected to how many other vertices by an edge. So now again look here, 1 is connected by 28 weight to 2. 5 is connected to 7 by 24. And then 4 is connected to 3 by weight 12. So 28, 24 and 12. So this is minimum. So we go over here and select as 3. Okay. After that, again in the next step, now 5. Now here we are going to 3. So the weight is 12. Now after that, 1 is connected to 2 by 28, 28, 28. 3 is connected to 2 by 16. 5 is connected to 7 by 24. So, and 4 is connected to 7 by 18. So out of 24, 18, 16, 28, minimum is 16. So now we select 2 as the next vertex. And what is its weight? Its weight is 16. After 16, after selecting the vertex 2, let us go to the next minimum weight. So we can take 28, 14. We can also take 14, 18, 24. So this can be taken. So out of this, which has the minimum value? So this 7 has the minimum. So now we have to select this 7. So I think this is the minimal spawning tree using the Prim's algorithm. Let me go ahead. So this is what it is, the minimal spawning tree is this. And what is the minimum distance? The cost of minimum spawning tree is sum of weights of all the edges. So 10, 10 plus 25 plus 22 plus 12 plus 16 plus 14, which is equal to 99. So this is the complete procedure with the example of Prim's algorithm. Let us take one more example. Now we have more number of vertices and more number of edges over here. So let us start from the minimum spawning tree can be obtained as, first we started from 0. We are independent to start from anywhere, but we are starting from 0. So 0 is connected with 1 and 0 is connected with 7. Right? So 0 is connected with 1 by 4 and 0 is connected by 7 by 8. So out of this, we take this one. After that, 1 is connected to 2 by 8. 1 is connected to 11 by 7. 0 is connected to 8 by 7. Okay, so we take as a next step, we take 7 and then again we can take the 8 because its weight is also 2 because its weight is also 8. After that, step number 3. So 0 is assigned. We cannot go back. 1 is also assigned. We cannot go back. Out of 7 and 2, either we should go to the 6. Either we should go to the 6 or we should go to the 8. And from 2, we can only, from 2, from 1, we can go to 2. So here, which is the minimum? So 6 is the minimum. So in the next step, let us go over there. 6 is minimum. So we assign this 6. After that, from 6, either we can go to the 5 by weight 2, or we can go to the 8 by weight 6, or from 1 to 2, we can go by weight 8. So out of this, which is the minimum? This 2 is the minimum. So we have to go to the 5. And then similarly, we are able to get all the vertices and all the edges, which gives us the minimal spawning tree. So this is the minimal spawning tree of the given graph.